We are going to look at identifying transformation and key features from equations. The examples I'm going to use here are from slides 2 and 3 in the Desmos activity on SLT 27. So if we take a look at this equation of y equals 5 times e to the x plus 3 minus 8, we are first going to identify the transformations. And these transformations are all from the parent function of e to the x. So anything extra we see is going to be a transformation because e to the x is our parent function. So when we're identifying transformations, we are looking at a, h, and k. We need to identify each of these values in order to better understand the transformations. And the way we can do that is by understanding just the general transformation formula, which is a times b to the x minus h plus k, where b is the base, so that's not a transformation. B just refers to the base of the function. In this case, the base is e. But a, h, and k are all transformations that are going to take place. So if we use that to help us figure out the transformation values, we'll see that a is the number being multiplied out in front, which is 5. We'll see that h is the value that is in the exponent with x, and it's going to be -3 because we have x plus 3, but in the transformation formula we see x minus h. When we have x plus 3, that's the same thing as x minus a -3, which is why -3 is our h value. Now for k is going to be the number being added or subtracted. In this case, it's -8. So I have those three values. Now in order to identify the transformations, I just have to understand what exactly a, h, and k do. Well, a is going to create a vertical dilation. And then if it's negative, it creates a reflection. And it's reflected over the x-axis. So that's the role of A. The role of H is going to be a horizontal, so left and right, translation. Translation just meaning shifting left and right, sliding. K is going to be a vertical translation. So using those definitions, we're going to take it back to our example here, and we're going to say, well, A is a +5, so it's going to be a vertical dilation by 5. And since it's positive, we don't have to worry about the reflection. Now for the H value of -3, -3 is going to tell me that it's going to be horizontally translated to the left 3. So we can just say that it's translated left 3. Lastly, the K value, the -8, is going to tell me that it's translated down 8. So that's the transformations. Now in terms of doing the key features, we'll go ahead and just kind of separate this. In terms of doing the key features, that means I need to identify domain, range, asymptote. And then I need to come up with either an increasing or decreasing intervals. So before we get into that, let's just look at the basic generic non-transformed key features. So whenever we're looking at exponentials, the domain of exponentials is always all real numbers. So no matter what kind of transformation takes place, left and right, it's always going to be all real numbers. So that one's easy enough, all real numbers. Now the range, however, will be affected by moving up and down. The range for my parent function here of e to the x for all basic exponentials, well, my range has always been affected by that asymptote. The asymptote is the values the graph is approaching but never touching. And the asymptote for parent functions is always 0. So my range values have always been y greater than 0. However, with the transformed scenario, now my range kind of has two different scenarios. It's either going to be y greater than or y less than, and that all depends on whether or not my a is positive. Well, since my a is positive, it's a positive 5. That's going to tell me that my y value is going to be greater than, and it's going to be greater than k. Because k is going to move me up and down, so the fact that it moves down 8 tells me that my asymptote of y equals 0 has now been moved down to y equals negative 8. And by moving my asymptote down to y equals negative 8, that has now changed my range to be y greater than negative 8. So the range and the asymptote always go hand in hand. This is always true for exponentials. Notice how I have 0 and 0, 8, negative 8, and negative 8. Okay, they always go hand in hand. In the last piece, in order to determine increasing or decreasing, again, I just need to decide if a is positive. Because as long as a is positive, that means I'm going to have an increasing function. So a is a positive 5. So there is no decreasing function. There is an increasing, and we always increase along the domain, so all real numbers. And a is clearly positive in the parent, right, because it's a positive e to the x. So here in the parent, it's an increasing function. And again, always increasing along the domain, so all real numbers.